Welcome back to your favorite math class this year. I assume you're all only taking one this year, so I get to be the favorite. Sitting here in my empty classroom, actually, working on this lesson for you guys today. And we are going to continue on with 15.1. I know this section seems like it's taking forever. And we're going to look at evaluating logs today. So again, the thing that I keep asking you, the answer to a log problem is a what? Gunnar? Yep, it's an exponent. Answer is going to continue to be the same, but the reason I keep trying to drill that into your brains is that if you can remember that piece, it's going to help the process of evaluating and solving things make much more sense as we continue to go along. Okay, so we're going to evaluate logs. We're going to not use our calculators unless you need to know them for cubing or squaring or things like that. Although in the first part of the packet, you do have the base numbers and you have like the base 5 is 525, 125, 625, etc. So that should help if you don't want to use your calculator. Try not to use your calculator on these. And you might be saying, but wait, our scientific and graphing calculators have the log button and they have an ln button, so why can't we just use those? Okay, well, first of all, remember that we said, I think it was in yesterday's, we said that if there's no number written here, it's assumed to be what? Katie, what do you think? Yep, it's assumed to be 10. So this expression here would mean that 10 to some power is 1,000. If it's an easy number like that, x is 3. You guys can probably do that faster in your head than you can punch it into the calculator, as long as you know to go back and forth between the log form and the exponent form. Okay, but so I've got a couple examples of different ones here. Okay, log 13. That's great. If you took your graphing calculator and or your scientific calculator, and the order you punch it in might be different depending on the calculator. In mine, I have to punch log first, then put the number, then put equal. Yours, you might put the number, then hit log. Play with it a little. But if I hit log 13, okay, this is a base 10 to the x power is 13. Well, that one makes sense to do in my calculator. I know that this answer is going to be somewhere between 1 and 2. And I don't know exactly where it is. Okay, so I can do that on my calculator. And that is actually, it's about equal to 1.114. There's some rounding in there. Okay, what about ln? Well, we didn't really talk about that, but ln means log base e. So in other words, e to what power is 13, or 2.718 blah, blah, blah to the x power is 13. Again, that one, not really doing in my head so much. I know that it's probably a number between 2 and 3, just estimating because 3 squared is 9 and 3 cubed is 27. 2.7 is not that far off. So it's probably a number between 2 and 3. So again, this one I could use my graphing calculator for, or my scientific calculator. I would push in natural log of 13, and I would find out that it is about 2.565. Okay, same kind of thing for these. Log of 0.42 means 10 to some number gives me 0.42. This is going to be a negative, and it's about negative 0.38. Natural log of 0.42, again, e to the x equals 0.42. I can't really do that in my head, so I'm just going to plug in natural log of 0.42, and I find out that that one is about negative 0.87. Okay, that's when you want to use your calculator. The problem is the log button only works if your base is 10. The natural log button only works if your base is E. Whole lot of other bases out there. So we're going to look at evaluating based on using what we know about exponents. Okay, so I'm going to end this video and start a second one just because, again, I know that when I upload to YouTube, there is a certain length of time before it has problems uploading. So I will catch you back here in just a minute.